Hello, and thank you for joining me today. Coming up in the news, the president is either on vacation or not, depending on who you listen to, but regardless, a 17-day-long TFR is gumming up the works over New Jersey. And there's a new competitor for the Cessna 172. And you'll never guess where the Chinese are building a new general aviation aircraft factory to turn out a new version of the old venerable Piper Cub. And a part of general aviation that you're all familiar with just turned 90 years old. Plus more listener questions and email. Welcome to Aviation News Talk, where we talk about, yes sirree, general aviation. I'm Max Trescott. I'm here to help you get smarter, faster, to try and keep you safe as a pilot or student pilot by sharing my over 40 years of experience as a licensed pilot, author, and the 2008 National Flight Instructor of the Year. Today, we're going to talk about turbochargers and the emergencies they can create. Even if you're not flying with a turbocharger now, you may in the future. And I want to share with you some of the common misconceptions that could save your life. Plus, listener questions on TAWS and activating legs of instrument approaches. All this and more, and the news starts now. From generalaviationnews.com, there's a presidential TFR, and it's huge. It's affecting virtually every airport in northern New Jersey, all the way from the New York state border down almost to the Philadelphia area. And it's also completely shut down two airports, Solberg and Somerset. Now, if you don't think this affects you, if you live in any of the states bordering New Jersey, please listen up. Let me give you an example that occurred out here in California a few years ago. There was a mechanic in Sacramento who was delivering an aircraft to Byron, which is quite a ways away from the San Francisco Bay Area, and he was totally unaware of a presidential TFR that was in effect, which had the normal 30 nautical mile radius. Well, it turned out that Byron was just barely inside that 30 mile radius TFR, and the Secret Service met him, and that was an automatic 90-day suspension of his license. So you can figure anytime you bust a presidential TFR, you can probably kiss your license goodbye for about 90 days. Now, this TFR is huge. It affects some of the border airports in Pennsylvania. And the National Business Aviation Association, NBAA, has asked the FAA to develop additional supplementary routes in and out of the New York City area. They say that this Bedminster TFR, which has a standard 10 nautical mile radius in the inner core, which is a complete no-fly zone, and it has a 30 nautical mile outer area all the way up to 18,000 feet, is scheduled to be in effect from now through August 21st. According to Dean Snell of NBAA, quote, "This one is primarily an airspace problem because it shuts down many of our route options in and out of New York City. It's like a 6-lane freeway with construction closing the center 3 lanes. Weather can then slow or shut down the outside lanes." He also noted that thunderstorms had blocked departures out of Teterboro, causing 3 to 4 hour delays at a previous TFR over Bedminster for the president. To get around the TFR, pilots will have to file routes provided by FAA ATC Command Center, which will be released daily in flight advisories. The FAA told Snell it was looking at and working on details of using more low-level routes. And from NewJersey.com, the local aviation industry say these visits to Jersey have cast a, quote, black cloud over their business during the peak flying season, costing them thousands in revenue. Now, the president has spent 4 weekends so far at the Bedminster Golf Club prior to this stay, and each of those trips have cost the two privately owned airports, Solberg and Somerset, an estimated $10,000 in profits, according to Jack McNamara, chairman of the New Jersey Aviation Association. He said that the 3-week August getaway is expected to be at least a $40,000 hit on the airport owner's bottom line. He said, quote, "Summertime is the peak time for airports to do their business. 2/3 of this business is done during the summer months into the autumn." Apparently, local airport owners have met with the Secret Service to ask for relief from restrictions while still being able to protect the president when he stays in New Jersey, but thus far no relief has been granted. And from avweb.com, solar eclipse affects general aviation. If you haven't heard already, August 21st is the date of a total solar eclipse here that's going to cross the entire United States. According to AvWeb in Oregon, GA airports in the path of totality are reporting that they are fully booked up for the event, and I can confirm that. I started to look at places to fly to in Oregon, and at this point, it's way too late to find hotel rooms, rental cars, camping sites, any of that stuff. So at best you're going to be able to do is fly into the area and hope that you might actually be able to land. According to this article, someone said we're actually getting requests from people down in California, Idaho, Washington, people flying in to go see the eclipse here, said Ron Peters, who manages the fuel facility at Salem Airport in Oregon. I read separately that they now have a waiting list for landing at Salem, Oregon on that day. Now, one San Francisco area flying club told AvWeb that more than half of their 50 planes are already scheduled to be in Oregon or Idaho for the celestial event. Well, I just completed my plans last night, and I'm going to be flying commercial out to Illinois to go visit my uncle, who lives in the southern part of the state, which also happens to be directly on the path of totality. Turns out my cousin's going to be in town, so we're looking forward to getting together, having a lot of fun, and watching the eclipse together. And if you haven't watched an eclipse before, definitely buy some of the special solar sunglasses or make yourself a projector. You do not want to stare directly at the sun or through, as some rumors have it on the internet, through a dark beer bottle. Not a good idea. And from AOPA.org, the Vulcanair single is expected to battle the Cessna 172. According to AOPA, Vulcanair is introducing to the U.S. a four-place high-wing entry-level Cessna 172 look-alike. They say that this aircraft can do everything a Skyhawk could do, plus a little bit more, and for about $100,000 less than the price of a Skyhawk. According to spokesperson Mike McCann, the aircraft is priced at $259,000, and he says that's an exceptional price point for an IFR-equipped entry-level four-place aircraft. It includes a digital avionics package based on the Garmin G500, so that's going to make it less expensive right there than the Garmin G1000, which is one way they're able to save some money. And the Vulcanair has the familiar look of a Cessna 172 with wing struts, fixed tricycle landing gear, and a wraparound rear window. Plus, this Italian-built model takes it one step further by providing a third door for rear seat passengers. Also, it's got a constant speed prop, which pushes the airplane to slightly higher numbers than a Skyhawk and gives a better useful load and higher ceiling. Just to look at some of the numbers, they say that the constant speed prop version should be able to climb at 900 feet per minute versus a Cessna 172, which is about 100 feet per minute less than that. And pilots can cruise at about 130 knots and 75% power, which would be about 10 knots faster than the Cessna 172. All of that from Vulcanair. And from GeneralAviationNews.com, word that the FAA administrator was at Oshkosh, and he said that the ADS-B deadline won't be changing. He started out by outlining a future with a thriving general aviation industry in America. He said, quote, "Someday in the not-too-distant future, your planes will still be sharing airspace with jumbo jets and helicopters, but also commercial space rockets, package delivery drones, aerial taxis, and other technologies that haven't even been dreamed up yet." He said, "One thing is for certain, the decisions we make today are going to shape that future." He said the FAA is working to become a more efficient and nimble organization, and that success comes down to a simple idea: partnership. He said, "If we're going to succeed in securing general aviation's future, we all have to step up." He said this is especially true of the January 1, 2020 deadline for pilots to equip with ADS-B. He also reminded the crowd that the FAA still has a $500 rebate available to help eligible aircraft owners offset the cost of installing ADS-B, and the deadline for those rebates is September 18th of 2017 to apply. And in international news, this comes from the HeraldNet.com, a newspaper in Washington state. This is a reverse of the typical outsourcing story that you usually hear. Top Cub Aircraft is building a manufacturing facility at the Arlington Municipal Airport in Washington state to build aircraft for the Chinese market. Now, they're an early arrival in what the city leaders hope will become a thriving manufacturing and industrial center in their future. Staffing will begin with 15 engineers and technicians when the facility opens toward the end of January and will grow to about 40 as demand dictates. Top Club is one of several modern derivatives of the classic Piper Cub that helped pioneer the small aircraft industry in the 1940s. The Top Cubs manufactured in Arlington will be sold only in China under an agreement with Yakima-based Cub Crafters, which owns the design and manufactures various Cub models for sale in the U.S. and in other countries besides China. After acquiring their production certificate from the FAA, Top Cub's goal is to manufacture 20 aircraft the first year at the new facilities, and they hope to ramp up manufacturing to 50 aircraft the following year. And from avweb.com comes this story that there's an unexpected side benefit of ADS-B, at least for owners of older jet aircraft. You may remember years ago, RVSM was instituted, which meant that for any aircraft to fly above flight level 290, they need to have special equipment installed so that they could then fly at 1,000-foot intervals. Well, many owners of older jets chose not to do that. They figured that the cost of installing RVSM was going to exceed the cost of the additional fuel that they would burn if they had to fly at these lower altitudes. Well, turns out there's now a new alternative for them, and it's a lot more cost-effective than the original RVSM is. According to this story, aircraft equipped with ADS-B out will no longer be required to specifically apply for approval to operate in the RVSM, the Reduced Vertical Separation Minima airspace, according to new proposed FAA regulations. Under existing regulations, to fly between flight level 290 and flight level 410, the aircraft must be RVSM certified either by the manufacturer or by subsequent application. The application requires the applicant to demonstrate the aircraft was equipped with an altimeter capable of a sufficiently high level of precision at very high altitudes, together with an autopilot capable of holding altitude within certain standards. Under the new rule, aircraft with ADS-B out will still need to have a suitable autopilot, but the ADS-B out system is deemed to comply with the altimetry requirement. This new rule, if adopted, is scheduled to become effective in 2018, and the FAA estimates it will save operators over $35 million over 5 years by allowing them to fly higher and save fuel costs. And finally, guess who's turning 90 years old? It's Flying Magazine. Boy, do I have great feelings and memories about this publication. As a teenager, I used to subscribe, and every month I would clip out that coupon that said I could have a first flying lesson for, I can't remember, $25 or something like that. I must have had a stack of 20 of those in my little safe. And of course, never used any of them, but did finally take flying lessons. I don't think my local airport accepted those coupons anyway. But boy, I have memories of having written a letter to Len Morgan, one of their well-known columnists, and getting a reply back from him back in probably the 1980s or 90s, back when people actually mailed letters back and forth to each other. The very first time I think I appeared in print anywhere was in Flying Magazine in the early 90s when I sent a letter to the editor in. They'd been talking about Trinca, which is a grass field in northern New Jersey, and I wrote a reply to the editor commenting about fond memories of flying into Trinca when I lived in Bud Lake, New Jersey, and used to work for Hewlett-Packard at their Rockaway, New Jersey division. And of course, I loved all their columnists. Gordon Baxter I thought was absolutely hilarious. And back in 2010, when EAA Magazine asked me to be a columnist, and I did that for a couple of years, it was always the Flying Magazine columnist that I was trying to aspire to be as good as when I wrote for the EAA Magazine. So a lot of great memories and fond feelings toward Flying Magazine. I didn't know all about their history until I saw this article, which was in Flying Magazine. So let me tell you a little bit about it. They say that it was created back in May 21st, 1927, when a Chicago ad executive, William B. Ziff Sr., had an idea. He wanted to capitalize on the frenzy of the Lindbergh solo crossing of the Atlantic. So he decided to create a magazine for aviation aimed at regular people who he was certain would now be motivated to learn to fly. That was the birth of Flying Magazine. Now, he was an aviator himself in World War I, and the result of his ideas and efforts grew to become the first issue of Popular Aviation in August 1927, which would eventually become Flying Magazine, well known as the world's most widely read aviation magazine. With his partner, Bernard G. Davis, Ziff would go on to found the successful Ziff Davis Media Company, which published several magazines, including Popular Aviation, Popular Photography, Popular Electronics, and other titles. When World War II came along, the focus of the magazine shifted to military aviation since there was almost no personal flying at the time. Popular Aviation was dropped and the name Flying adopted. After the war, with returning GIs eager to learn to fly in light airplanes like the Piper Cub, the Aeronca Champs, Aircoups, and others, Flying flourished and its audience grew. Today, Flying remains the most popular newsstand aviation magazine in the world and has expanded into multiple brand channels online that include video, photos, the Flying e-news, and a strong social media following. The magazine is produced each month by a team led by editor-in-chief Stephen Pope and still includes many aviation luminaries on the masthead, including Peter Garrison, who has written for Flying for more than 50 years. And of course, I should also add my very good friend Rob Mark, who's senior editor at Flying Magazine. So hats off to Flying Magazine. Congratulations for 90 years. I absolutely love you guys and hope you have another 90 years of success ahead of you. Well, that's the news for this week. Coming up in a moment, we're going to talk about turbochargers and how to handle emergencies with them. And that's important because someday you may be flying one. Plus, more listener feedback about flying the traffic pattern at non-towered airports, plus listener questions. We'll be right back. And welcome back. Hey, before we talk about emergencies with turbochargers, just a few quick updates from here. I mentioned last week the new Instagram account, and you can see the photos I take when I'm out flying around. In the last week, we've got photos of a really cool firefighting helicopter, a Sikorsky S-58ET, which was built back in 1958, I think. It landed at Palo Alto, so I posted some great photos of that really, really cool-looking helicopter. Also, folks, we've got pictures up of Prime Air, so if you belong to Amazon Prime, you can see pictures of their 767s that I saw when I flew into Stockton Airport this past week, as well as some pretty pictures over the Monterey Bay and Santa Cruz that I shot as well. So just go out to Instagram and look for Aviation News Talk. And a quick shout out to Evan Shue from Australia. He was here on Monday this week visiting, and we flew together in a Cirrus SR-20, did a bay tour. It was a little bit cloudy, but we were still able to find the Golden Gate Bridge down in there, flew over Alcatraz and other sites in and around San Francisco, and then came low along the coast to come back to Palo Alto. And I just had an email today from someone in Canada who wants to do something similar. And I do want to say we have a lot of listeners in Canada, so I probably don't mention you often enough, but thanks so much for listening to the show. And anyone who finds themselves in the Bay Area, give me a couple weeks advance notice, and we'd be happy to set up a tour with you to fly around the area in a Cirrus. Survey results. Hey, I want to thank everyone who's taking this month's survey, asking about what flight planning tools you use when you're planning longer trips. I've learned from Evan and some others about flight planning tools you have in Australia, so I've added Oz, Runway, and Avplan to the list of choices that you can select when you take the survey. Just go out to aviationnewstalk.com/survey. And this is the part of the show where I talk briefly about ways you can support the show. And of course, number one, Patreon. I want to thank the additional supporters we picked up this past week. Looks like, about 6 or 7 of them. And they are Joe Crabb, Brian Brisk, Ken Mercer increased his contribution, Alan Markham, Greg Holbrook, Stephen Devine, and Michael McKean. And by the way, Michael did a custom contribution, so you don't have to pick the levels that are shown there on the right side of the page. You can pick any random amount. So if you don't like the levels we have suggested here, just right below the picture, click on the Become a Patron button, and then from there, you're going to go ahead and look for, at the upper left-hand side, a large orange Continue button, and just type a number in that little box next to Continue. Looks like they stick $2 in that box, and it's not obvious you can change it, but just click on that $2 and put in any amount that you would like. Speaking of the Patreon page, I've just posted a NASA-created map of all the airports that will be in the path of this upcoming solar eclipse. So if you'd like to pick the closest airport to you, go fly out and view the eclipse. It's going to be one of the best ones to see in quite a long time. So speaking of the Patreon page, anybody can see that story I've just posted about NASA. And you go out to aviationnewstalk.com/awesome. And of course, just click on the word post near the top of the page. While you're there, check out the goals and consider supporting the show with a donation by credit card. You probably know for the month of August, we're trying to fund the development of 2 apps so that non-techie pilots can find us in the Apple iTunes and the Google Play Store. And of course, if you're able to help by making a contribution of any amount, I'll read your name here on the show. Thanks so much. Really appreciate all your support. Hey, and stick around because in 7 seconds, we're going to talk about turbocharger emergencies and talk about some things that really could either save your life or certainly save you a whole lot of money. We'll be right back. And welcome back. I thought I'd talk about turbochargers because even though you may not be flying one today, you might sometime in the future. And hopefully this will give you some helpful information that could save your life or perhaps save you a whole pile of money. Now, I spoke with a pilot over a year ago who had a turbocharger failure. And I learned from talking with him that he had some of the same misconceptions that I had before I took a course from the Cessna Pilots Association back in the year 2000, which was when I bought a Cessna T210. Now, that's a turbocharged 6-seat retractable aircraft. Now, the pilot had his turbocharger fail in flight, and like me at the time, he didn't view this as an emergency. He'd previously had a failure of the turbocharger, and after he landed, a mechanic found it was just a loose clamp. He tightened it and said everything was fine. So this pilot thought that he was having the same problem again, and he thought that in general, turbocharger failures were not emergencies. Now, if he had realized that this failure was an emergency, he had plenty of time to land at the closest possible airport where they could have done very minor repairs to the aircraft. Instead, he continued flying for some period of time, trying to troubleshoot the problem, trying to decide, which airport to land at, where he might be able to get the best possible maintenance, when suddenly the windshield was covered with oil and the engine quit. He tried to glide to the nearest airport, but he came up a little short, so he had to land in a field, and in the process, the aircraft was totally destroyed. Now, he survived, but things could have been a lot simpler if he'd known why it's important to not just land as soon as practical, but to land as soon as possible if you have a turbocharger failure. And of course, it's easy to tell when you have a turbocharger failure. When things are working well, your manifold pressure is going to be relatively high. If you're turbo normalized, up around 29 inches. If you're turbocharged, it could be 32, 35 inches, something like that. But when the turbocharger fails, suddenly you're flying a normally aspirated aircraft, and you're going to see manifold pressure levels that are much lower. If you're at low altitudes, a few thousand feet above the ground, they might be as high as perhaps 24, 25 inches of manifold pressure. At higher altitudes, up around 10,000 feet, you might only see maybe 20 inches of manifold pressure. So the drop could be substantial. You might see a 10-inch drop in manifold pressure, and that's going to tell you immediately that the turbocharger has failed. Now, it would be easy to rationalize that and say, well, so now I have a normally aspirated airplane. What's the big deal? Well, we'll talk about that in a moment. But suffice it to say, it is a big deal, and you need to land as soon as possible. So let's talk about how a turbocharger works. You can think of it as being two small fans which are connected on the same metal shaft so that they're both spinning around at the same time. Now, one of these fans is called the turbine, and it sits in a pipe which has exhaust gas coming from the engine cylinders. As the hot gas blows past the fan blades, they're going to rotate the shaft, and that shaft is then going to rotate the second fan. Now, the second fan is called a compressor, and it's located in a pipe which is basically bringing in cool, fresh air from the outside. And what it's doing is that it's compressing that air so that you now have a high level of air pressure going into the engine. So think of it this way. Exhaust gas, hot gases on one side of this turbocharger are driving the device, and on the other side of the turbocharger, the cold side, cold air is being compressed so that you have higher pressure air going into the engine. And by doing that, you can keep the engine thinking it's at sea level, so it effectively produces the same amount of power at maybe 20,000 feet as it produces down at the surface. Now, here's the problem. If the turbocharger fails, let's imagine it fails on the cold side. That's the side where the cold air is coming in from the outside and being compressed. Well, a failure on that side means you have a leak and you probably are not able to compress the air. But any leak that you have is relatively cold air, which is going to be harmless. And that's probably what happened the first time the pilot I talked about had a loose clamp. When they landed, they just found that, okay, there's a leak on the cold side. No problem. We'll tighten the clamp as it's working again. But now imagine that you've got some kind of leak. It might be, let's just imagine we've got a hole that's eroded into the pipe on the hot side. Well, on the hot side, you have gases that are running about 1,600 degrees Fahrenheit. Imagine a hole somewhere in the piping. You're going to have basically a blowtorch, which is somewhere inside your engine compartment, blowing hot gases onto who knows what. Well, you can see pretty easily that if it's on the hot side, you have an emergency, because that could be burning different hoses in there. It could be burning who knows what. It could be starting a fire. Clearly, it's a full-blown emergency. You need to get on the ground yesterday. So you're going to land at the absolutely nearest suitable airport. And by that, I mean any runway that's long enough to get onto. That's where you're going to go. Now, here's the problem. When you have a turbocharger failure, when you're sitting in the cockpit and you watch the manifold pressure drop suddenly, there is no way to tell whether it's a good failure or a bad failure. In other words, there's no way to tell, is it a failure on the cold side or is it a failure on the hot side? So in the case of the accident pilot I was talking about, his first failure, probably on the cold side. His second failure, most likely on the hot side, which led to loss of oil and then a failure of the engine. So if you have a failure, you have to treat it as an emergency because you have no idea whether it's a good failure or a bad failure. Anytime manifold pressure drops, get on the ground yesterday. And while researching this topic, I came across an old article from Plane and Pilot magazine back in 2008, and it says, naturally, you should be trained in the finer points of turbocharged engine operation in accordance with what the engine and aircraft manufacturers have to say. Problem is, the manufacturers haven't been saying enough. And they write, a few months ago, an NTSB issued safety recommendation called on the FAA to complete action on something that was asked for back in 1994. Back then, the NTSB had been investigating an accident involving a Cessna T210, similar to the one I used to own, which experienced a partial loss of engine power and crashed short of the runway, killing 2 of the 5 people on board in Arizona. Now, there was a problem with the engine's turbocharger, but the pilot didn't realize it. He turned on the fuel boost pump while descending, and the engine lost additional power. Now, the NTSB felt that pilots of turbocharged aircraft weren't being provided with enough information about the emergency procedures for identifying and dealing with turbocharge failure. And so they gave a recommendation to the NTSB that manufacturers be required to put this kind of information in POHs. The FAA agreed in 1995 with the NTSB's intent, but they thought that it wasn't necessary to issue an airworthiness directive to force compliance. Instead, they just encouraged manufacturers to voluntarily provide enhanced information. Well, fast forward to 2008, there was another Cessna 206 turbocharged crash. And again, the only person on board, the pilot, was killed. The NTSB discovered that the turbocharger had failed, and in looking at the airplane's POH, they found that the emergency procedures didn't give any clear guidance or specific instructions. So in 2008, the NTSB once again made the same recommendation to the FAA, asking them to require manufacturers of aircraft equipped with engine turbochargers to amend their POHs and airplane flight manuals to include an emergency procedures section with information regarding turbocharger failure, and specifically procedures for minimizing hazards related to in-flight fire and/or loss of engine pressure. Now, the FAA does advise in the Airplane Flying Handbook that if there is an overboost condition, that is, the engine is producing excessive manifold pressure, you should retard the throttle, that is, pull it back, and operate the engine so as to avoid a further overboost condition. The FAA also says that if you see low manifold pressure, it might be a minor problem or a major exhaust leak, and you should use the lowest possible power setting and land as soon as is practicable. Now, by the way, you notice practicable, some of the checklists we'll be talking about in a moment don't say as soon as practical. Instead, they say to land as soon as possible. So now let's look at some checklists for handling turbocharger system emergencies. I'm sure most listeners know that I specialize in the Cirrus, and so I had at my fingertips the Cirrus SR22 Turbo POH, and they had a lot of good stuff here. So let me take a look and see what we have here from Section 3, which is the emergency section. Unexpected loss of manifold pressure, which, of course, as we described earlier, could happen from either the hot side or the cold side of the turbocharger. So unexpected loss of manifold pressure, which, of course, is what the accident pilot I described had the problem with. Number 1, power. Adjust to minimum required for sustained flight. So think about that. You're going to pull the power back, and if there's flame coming out of one side of your turbocharger, you know, that flame just got a little bit smaller. The temperatures went down a little bit. So that's going to help things right off the bat. Reduce power. 2, mixture. Adjust for EGTs between 1300 and 1400 degrees Fahrenheit. 3, descend to minimum safe altitude from which a landing may be safely accomplished. 4, divert to the nearest suitable airfield. And when it says suitable, I think that means any airport that's long enough for your aircraft to land at, and of course wide enough. Number 5, radio. Advise ATC landing is urgent or transmit on 121.5. Mayday, giving location and intentions when workload permits. Oil pressure monitor. And of course, we mentioned that the accident pilot I talked with lost oil pressure. 7, land as soon as possible. not as soon as practical, but land as soon as possible, which means immediately. And they give an amplification in which they talk a little bit more about this. They say that if the aircraft experiences an unexpected loss of normal manifold pressure, the engine will typically revert to operation similar to a normally aspirated aircraft at approximately the same altitude. However, continued flight should only be conducted to the nearest suitable landing place in order to investigate the cause of the unexpected loss of normal manifold pressure. And they give four possible causes for that. One, a leak or rupture of an induction system coupling. So that would be on the cold side, some leak in the air that's occurring to be compressed in the compressor. And they say that this condition does not usually present a significant hazard other than power loss equivalent to a naturally aspirated engine. But they say while this is the most probable condition, the following three conditions may present an immediate hazard to continued safe flight. And because it's difficult for pilots to distinguish between a simple induction system leak and any of the more hazardous causes, all unexpected losses of manifold pressure should be assumed to be hazardous. Then they go on with numbers 2, 3, and 4. Number 2, a significant leak in the exhaust system. It says an exhaust leak may present a possible fire hazard. Reducing power and adjusting the mixture as described reduces the possibility of an engine compartment fire. And then they give number 3, which would be a loss of oil pressure to the wastegate actuator due to a general loss of engine oil pressure. And of course, the accident pilot we talked about in the beginning here did have a loss of engine oil pressure. And they give possible reasons why that might fail. And then finally, number 4, a failure of an internal component of the turbocharger. So bottom line, if you have an unexpected loss of manifold pressure, get the heck on the ground immediately. So let's take a look at another emergency. Manifold pressure is high. And in the Cirrus, you would get a manifold pressure warning when you do that. By the way, this sometimes happens on the takeoff on a cold day with any turbocharged engine, and that's because the wastegate may not be moving as freely as it will once it warms up. And so sometimes we'll get an overboost because that wastegate is not opening up enough. And so excess exhaust gases are turning the compressor to too high a level. So if you do end up with a high manifold pressure, especially on takeoff, these are the steps to perform. Pretty simple. Number 1, power level. Reduce manifold pressure to less than 36.5 inches of manifold pressure. Now that exact number would be different depending upon the aircraft that you're flying, but in this aircraft, you'd bring it back to 36.5 inches. 2, flight. It says continue. And then it says if noticeable surging is present, 3, perform the overboost pressure relief valve checklist. And then it goes on and says some of the things I just mentioned. It says high manifold pressure may be a result of cold oil and the effect of high associated oil pressure on the wastegate controller. Okay, so if there is noticeable surging, we should move down to the next checklist, which is the overboost / pressure relief valve checklist. It says step number 1, power lever reduced to 30.5 inches of manifold pressure or less. So that's a significantly lower reduction than we had in the prior checklist item. 2, mixture adjusts fuel flow to the top of the green arc. So you're going to want to have as much fuel flow as practical. And then it says if continued surging is present, land as soon as practical. Now there's some more information here in the amplification. It says, although it is an unlikely failure mode, the wastegate may be stuck in a closed position, which means all of the exhaust gas is being used to run the compressor. And it says if pressure relief valve is obviously surging, and in parentheses they explain surging by saying cycling high manifold pressure followed by sudden drop to lesser pressure may be accompanied by pop noise. It says it may be evidence of manifold pressure controller setting problem, but may also be evidence of a seized wastegate. Engine will be adequately protected by the pressure relief valve, but turbo overspeed may result in turbo failure if pressure relief valve remains open. So reducing manifold pressure via the power level will decrease the airflow through the engine, thereby reducing the energy available to drive the turbine. Enriching the mixture will maintain low turbine temperatures. It is unnecessary to descend prematurely. Lower altitudes and high density altitude may aggravate the condition. And for the final checklist here, we have the turbine inlet temperature high warning. So, of course, the turbine inlet temperature is the temperature measured of the exhaust gases that are entering the hot side of the turbocharger. And if you get the TIT warning, Number one, mixture, adjust fuel flow to top of the green arc. So you want to get more fuel flow because that could be one of the reasons the temperatures are high. Two, ignition switch, check that it's on the both position, because if you're in the L or the R position, temperatures will be higher than they are in the both position, and that's true for all general aviation engines. And then it says if TIT limits remain in excess of limits, power, reduce, and B, land as soon as practical. And in the amplification, they say annunciation indicates that one or both turbochargers are exceeding turbulent inlet temperature limits. Condition may be reduced and controlled by mixture management, but may be a sign of improper combustion or magneto failure. Well, so that's our discussion here for turbocharger emergencies. Please file that away in the back of your mind. Anytime you incur a sudden loss of manifold pressure in a turbocharged aircraft, please land immediately at the most suitable runway that's close to you. Coming up, we have lots of listener feedback and questions. One Cessna 172 owner asked how to stay proficient in a Cessna 182 that he occasionally rents when he needs a more capable aircraft. We'll be right back. And welcome back. Let's see, no new iTunes review this week. If you're in another country outside the U.S., please go ahead and put a review up there. We don't have too many reviews up in the other countries outside the U.S. Listener feedback. Kenneth in Louisville, Kentucky says, just a shout out for your fantastic podcast for GA. I passed my private check ride on July 31 and really appreciated the info you've shared on this podcast. Listened to it since day one. Thanks for everything you do for the industry. Thanks, Kenneth. Congratulations on your private ticket there. That's pretty awesome. And I sent him an email and I told him that this is when the learning really begins. Everybody talks about getting your private license, that it's a license to learn. And it's true. You're going to learn a whole lot of new things after you get your license. Here's a email from Greg. Just part of the email, he says, I have often heard the advice to find a plane that meets 80% of your mission, then rent or charter an aircraft when you need a more capable plane. And that's exactly, by the way, what I tell folks who are interested in buying an aircraft. The theory there is if you buy an aircraft that fits 100% of your needs, you're probably going to be overbuying. Just imagine I'm here in California. Most of the time I'm running up and down the West Coast, but every once in a while, once a year, I need to go to Florida. Well, I'm certainly not going to buy a jet because I occasionally go to Florida, but I might choose to fly the airlines, or if I were really wealthy, use NetJets or something like that. So anyway, if you buy an airplane that meets 100% of your mission needs, you're probably overbuying. But he says, in this case, how does a pilot stay proficient in a plane he or she only rents on an as-needed basis? Let's take my situation. Let's assume my 172, which he currently owns, meets 80% of my flying mission, and I can rent a 182 for those more distant destinations, or when we want to take another couple along. I know it depends on the pilot, how many hours flown each year, but would flying a more capable plane 20% of the time be enough to stay proficient? And I emailed back to Greg, for any plane you fly infrequently, I think the best insurance is hiring a CFI for an hour to do some pattern work. That should get you well tuned up for any upcoming trips. I also said that at my club, people need to fly in a particular aircraft type every 60 days. Otherwise, they need an hour in the plane with a CFI. And Greg, thanks for that question. Greg, by the way, is one of our Patreon sponsors. And I've been exchanging email with Miller, also on Patreon. We were talking about people who just don't like the extra time it takes to enter on the 45 at non-towered airports. And he said, a little caveat I try to live and fly by, don't fly like it's an emergency unless it is an emergency. Just because it takes longer is not an emergency. Short of a true emergency, there really is no good reason to deviate from the standard procedure in my book. Best regards, Miller. Thanks so much for that. And Trevor says, last week you had a listener write in saying that you were using the wrong term of the traffic pattern, saying that you should say you're on the departure leg of the pattern and not on the upwind. Though it might be technically correct, I believe it's not the safest option. Where I live in the Phoenix and Tucson areas, we have a lot of flight schools, and many of the students' English is not their first language. Using the term departure leg and departing the pattern can sound very similar to a non-native speaker. As soon as the word depart is heard, I feel that it can easily be misinterpreted that the aircraft is intending to leave the airport and not stay in the pattern. This is also fueled by the fact I hear ATC call this portion of the pattern upwind as well. I know using departure leg might be correct, but I'm going to go on the safe side of safety and stick with upwind. Yeah, Trevor, I agree. The word depart definitely sounds like you're going to be leaving the airport. I sometimes have students say that they are departing runway 32 and then never mention that they're staying in the pattern. I think that's pretty misleading. So, anyway, people should probably conform to what the norms are in their area and, when possible, go ahead and fly the recommended procedures.
Hello, Max. Ruben here from the Netherlands. Short, simple question. What is TAWS and why would we want to have it? TAWS, TAWS, something with terrain. And in which avionics is it normally integrated? A separate module, or is it integrated into the Garmin GPS navigators? Thanks very much, and keep up the good work. Thanks.
Ruben, nice to hear from you again from Europe. First, TAWS stands for Terrain Awareness and Warning System, and I'm going to go ahead and read from my Max Trescott's G1000 and Perspective Glass Cockpit Handbook. TAWS provides the oral and visual alerts for hazardous terrain. It's an option in most G1000 and all Perspective aircraft. TAWS uses GPS information to determine position and altitude. GPS altitude is converted to height above geodetic sea level, that's GSL, which is used to determine TAWS alerts. GSL altitude accuracy is not subject to variations in pressure and temperature, making it a reliable source to calculate terrain and obstacle alerts. In TAWS-equipped aircraft, there's a TAWS page, and the system provides the flight crew with sufficient information and alerting to detect potentially hazardous terrain situations that would permit the flight crew to take effective actions to prevent controlled flight into terrain. The basic TAWS functions, of which there are several, are 1. A forward-looking terrain avoidance function, that's FLTA. It looks ahead of the airplane, along and below the airplane's lateral and vertical flight path, and provides suitable alerts if a potential CFIT, that's controlled flight into terrain, threat exists. Now, the second function is called the Premature Descent Alert function, the PDA, and it uses the airplane's current position to determine if the airplane is hazardously below the normal typical 3-degree approach path for the nearest runway. And TAWS also provides caution and warning alerts. So, for example, in the G1000, that implementation includes warnings such as excessive rates of descent, gives a negative climb rate or altitude loss after takeoff. Kind of interesting. So if you're not climbing when you take off, you get a warning. And you get a voice call out 500 when the airplane descends to 500 feet above the nearest runway elevation. And yes, this is definitely associated with the GPS function of most aircraft. Now, I had a listener contact me this week about something, and after I replied, he wrote back, "Oh, I didn't realize you were the Max Trescott who wrote the G1000 book that I just purchased." So obviously, I'm not talking about this enough. So if you are interested in my Max Trescott G1000 book, just call 800-247-6553 and they'll ship a copy out to you.
Hi, Max. This is Bill Rote. I've got a couple of questions for you related to IFR approaches. I can never seem to remember the right procedure to activate a leg as opposed to activating direct to a specific waypoint on the approach. Anyway, hope those are useful discussion topics. They're ways I tend to get sideways in the Garmin GPS and could use your advice on that. Thanks for a great podcast. Appreciate it.
Bill, thanks for your question. It's answered in both of my books, both the G1000 book and the IFR book. And to activate a leg, all you need to do is to put your cursor on the second of the pair of waypoints that define the leg. And after you have that cursor on the second waypoint for the leg that you'd like to activate, then just hit the menu key. Activate leg will already be selected as the first choice, and then hit enter, enter. So basically, highlight the second waypoint, hit menu, and then enter, and you have activated that leg, which means that the autopilot, for example, can now intercept and fly along that particular leg that you've highlighted. And hey, it looks like we now have gone through all of our recorded listener questions. So if you have a question you'd like to ask, go out to aviationnewstalk.com, click on listener questions at the top of the page. And then at the bottom, you're going to see a little green start recording button. And that way you can send a voice message here and we'll put you on the air. And that, my friends, is going to wrap it up for this week. Hey, thanks to everyone who has contributed on my Patreon page. We're getting really, really close to my August goal of being able to fund some apps for the Apple App Store and Google Play Store. So you can contribute as little as $2 a month. The cost is billed to your credit card. Just type into your web browser aviationnewstalk.com/awesome. And if you're thinking of buying a new or slightly used Cirrus, please contact me early in the process. I work with people around the country. Love to help you with some of the decision criteria that you might not have thought about. And if you love the show, please share it with your friends. Show them how to find this podcast. And until next week, fly safely, have fun, and keep the blue side up.